Very good morning. Welcome to the channel Math Physics Academy, and today we have brought some of the questions related to electric charges and fields. This particular chapter is the very first chapter in Standard 12 of CBSE. We will be looking for some of the important questions which already appeared in the board examinations earlier, and those questions we will be solving for conceptual clarity. Right. Let us solve some of the questions. Now, we will be utilizing some of the basic formulas. Basic formulas in the sense that we already know about charges. There used to be a positive charge and a negative charge. We also know that like charges repel each other, means positive or negative charges will be repelling each other, and unlike charges will attract each other. Positive and negative charge will attract each other, and negative and positive charge will attract. Fine. So that is there. We also know some of the properties of the charges, like additivity of the charges. The charges can be added together. The total charge on a body, if separate charges Q1, Q2, Q3 is given to that particular body, so the total charge additivity property by which we can find total charge is equal to Q1 plus Q2 plus Q3. The another property is charge is always conserved, means charge is always constant, it will not be lost. Okay, that is called conservation of charge. Similar to conservation of mass and conservation of energy, charge is also conserved. The third property is charge Q is always expressed as an integral multiple of electronic charge. Q is equal to NE. Right? A charge is always expressed as an integral multiple of electronic charge E, that is Q is equal to NE. We also know about Coulomb's law. Okay, as per Coulomb's law, the force of attraction or repulsion between two charges Q1 and Q2, okay, between two charges Q1 and Q2 can be found as 1 by 4 pi epsilon 0 product of the charges Q1 and Q2 divided by the square of the distance between them, that is called inverse square law. So in this way we can find force between two charges. This force can be of attractive force and this force can be repulsive force. Fine. We also know that electric field is expressed as force per unit test charge, right? Per unit test charge. So we can always write that electric field can also be found as 1 by 4 pi epsilon 0 Q by R square. Okay. We will be utilizing this concept of finding electric field. That's why I am explaining here. Okay, electric field is expressed in the unit Newton per Coulomb. Newton per Coulomb. Okay, Newton per Coulomb. And force is always expressed in Newton. Okay. Now let us see. So here it is given question number 1. Two concentric metallic spherical cells of radii r and 2r are given charge Q1 and Q2. Two metallic spherical cells are there of radius one is of radius r and another one bigger metallic spherical cell is there for which the radius is 2r. Both of them are given charge, like this first spherical cell is given charge q1 and another one is given charge q2. Now the surface charge densities on the outer surface of the cells are equal. So suppose surface charge density is sigma 1 on this spherical cell and sigma 2 on this spherical cell. So it is given as sigma 1 is equal to sigma 2. So what is surface charge density sigma? It is total charge per unit surface area. Total charge per unit surface area. Okay, so we will find both of them. So like this, already we are given surface charge density sigma 1 is equal to sigma 2. It means we can write q1 by the surface area of this sphere, that is 4 pi r square is equal to q2 by 4 pi into 2r whole square, right? This 4 pi we have cancelled. Again we are going for, we are writing as q1 by r square is equal to q2 by 4r square. This r square also will get cancelled, and we will be able to find q1 by q2 ratio, which is being asked in the question as 1 by 4. So q1 q2 ratio is 1 by 4. Moving to next question. Here, deduce the expression. We need to derive the expression for the electric field E at a point R due to a system of charges Q1 and Q2 with position vectors R1 and R2 with respect to common origin. Right? Okay. So suppose we'll draw a figure. Like this is x-axis and this is y-axis. Suppose a charge Q1 is placed at point A, Q2 is placed at point B, and we need to find electric field at some point P, which is placed in R distance from the origin. So suppose this distance is R1, this distance is R2, right? Vector, these all are vector. Okay, R2 is also a vector, and this distance from origin, it is at R vector. The distance of A from P, right, and the distance from B to P, so BP and AP. We have to find the electric field at this particular point, right? We need to find the electric field at this particular point P, E. So it means the electric field due to this Q1 will be in this direction, right? Due to this Q2 will be in this direction. Okay. So here we are finding that almost all between E1 and E2. So E1, here it is E1, and here it is E2. Almost the angle between these two, E1 and E2, seems to be 90 degree. So cos 90 degree will be equal to 0 even if we are using that parallelogram law. Okay, so but here we are going for vector notation, and in that vector notation let us find out that electric field. So AP, the distance AP we have to find, and that distance will be equal to R vector minus R1 vector. Similarly, the distance BP is R vector minus R2 vector. Okay. Now electric field due to Q1 is equal to 1 by 4 pi epsilon 0 Q1 by magnitude of R minus R1 vector, that is cube, and here it will be R minus R1 vector. In vector notation we are writing. We are writing in vector notation. Okay. Similarly, EQ2 will be 1 by 4 pi epsilon 0. We know 1 by 4 pi epsilon 0 is equal to 9 into 10 power of 9. 9 into 10 power of 9 Newton Coulomb square per meter square. Sorry, Newton meter square per Coulomb square. Okay. So 1 by 4 pi epsilon 0 Q2 and magnitude of R minus R2 cube, and here R vector minus R2 vector. So the net electric field E will be equal to EQ1 plus EQ2, and this electric field is also in vector notation, and we can write as 1 by 4 pi epsilon 0, which is common to both of them, and we can write Q1 by R minus R1 whole cube R minus R1 plus Q2 by magnitude of R, it is not there, R minus R2 cube R minus R2 vector. So this is the net electric field we can find out. Okay. Now going to question number 3. Yes. So in this it is given an electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude so and so, 2 into 10 power of 4 Newton per Coulomb. So we are given distance, okay, in a uniform electric field, and figure is also shown. Distance is 1.5 centimeter, which we can write as 1.5 into 10 power of minus 2 meter, and the figure A is given as like this. This will be the figure A. Okay. And in this figure A, if this is positive plate, this is negative plate, uniform electric field will be in this direction. Okay, electric field is in this direction, and then electron is falling, and this distance is given as D, 1.5 centimeter. Okay. So in this case, this is figure A. Similarly, it is given if the direction of the field is reversed, keeping its magnitude unchanged, calculate the time taken by a proton to fall. So in second figure, that is figure B, Okay, that is figure B. So this will become plus because direction of field is reverse. Direction of field will be in this direction, electric field, and a proton falls here, P, which is positive charge. Okay, proton falls. Right. Now we already know the mass of electron. Charge on an electron is equal to 1.6 into 10 power of minus 19 coulomb, which is equal to the charge on proton also. Okay. Similarly, means this is equal to charge on proton also. Mass of electron is equal to 9.1 into 10 power of minus 31 kg, which will be given to you in the examination, no need to worry. Mass of proton will be equal to 1.6 into 10 power of minus 27 kg. Right? This we are going to utilize. Now we know that the force on electron, the force experienced by an electron will be the charge on an electron E and the electric field. Okay, charge on an electron and the magnitude of electric field. So Fe will be mass of electron and acceleration of an electron. That acceleration gained by the electron in falling down will be equal to E and electric field. So further we can calculate acceleration of electron from here, that is EE by ME, by putting the values. Please calculate yourself. Okay, I have calculated, so I am telling you directly, because E value also we are knowing 1.6 into 10 power of minus 19. This electric field value also we are knowing 2 into 10 power of 4 Newton per coulomb. Okay, electric field value is given 2 into 10 power of 4 Newton per coulomb. Okay, so by substituting all those, mass of the electron 9.1 into 10 power of minus 31 kg, we will get acceleration as 3.5 into 10 power of 15 meter per second square. Okay, now we will utilize the equations of motion, that is S is equal to ut plus half at square. Now you see here is starting from rest. So what? U is equal to 0. So this will be S is equal to half at square, and time we can find as 2S divided by A. With this formula, by utilizing this formula, we can substitute S. S is what? This is only S is equal to S is equal to D is equal to 1.5 centimeter, which is 1.5 into 10 power of minus 2 meter. So if we will be calculating this one, 2 into 1.5 into 10 power of minus 2 divided by 3.5 into 10 power of 15 meter per second square, we will get T value as 9 into, okay, right, we will get as 9 into 10 power of minus 9 second. Okay, so it is 3 into 10 power of minus 9. So we will get the value as 3 into 10 to the power of minus 9 second. Okay, this will be the time. Okay, now similar case will be there when we are finding for proton. When we will be finding for proton, same thing it will be there, all the process will be same, acceleration will be different. So in that case, acceleration of proton will come as 2 into 10 power of 12. Acceleration will get as 2 into 10 power of 12 meter per second square. Okay, meter per second square we are going to get it. Acceleration of proton. Then further when we will be calculating, okay, we will get the value time in the similar process. We will get 1.22 into 10 power of minus 7 second. Okay, square root of 1.5 will be coming into 10 to the power of minus 14, which can be calculated as t is equal to 1.22 into 10 to the power of minus 7 seconds. Same procedure for the proton also. Right. In case you find difficulty in calculating, please put on comment. I will certainly reply with detailed calculations also. Coming to question number 4. This is very 1 mark question type. An electron experiences a force 1.6 into 10 power of minus 16 Newton in an electric field E. So the electric field E has to be calculated. We know that E is equal to F by Q, and here Q is QE, electronic charge. So we can very well calculate electric field is equal to 1.6 into 10 power of minus 16 it is given, and electronic charge on an electron is 1.6 into 10 power of minus 19 coulomb. So this 1.6 and 1.6 will get cancelled. 10 power of minus 16 into 10 power of positive 19, because it will go up and it will become positive. So Newton per coulomb, which will be given to you as 10 to the power Newton per coulomb, or 1 into 10 power of 3 Newton per coulomb. In scientific notation we can write. Okay, right. This was question number 4, and question number 5, gentlemen, it is solved. So 2 point charges, okay, plus Q and minus 2Q are placed at the vertices B and C of an equilateral triangle ABC of side A. Obtain the expression for magnitude and direction of resultant electric field at the vertex A due to these 2 charges. Now we will make the figure. It is made in this way. Suppose this is A, this is B, and this is C. In B, plus Q charge is kept. In C, minus 2Q charge is kept. We have to find the resultant electric field at the vertex A. We know that the electric field due to this Q charge, which is kept at B, will be in this direction. So this is, suppose, E1. Okay, and the electric field due to minus 2Q will be in this direction. So this is actually E2, and the resultant electric field will be in this direction. That will be resultant electric field E, whereas E1 and E2 we will see, okay, resultant electric field ER, we can say ER. And the angle between E1 and E2 will be 120 degree. Okay, why? Because this angle is 60 degree. It is an equilateral triangle. So the angle between E1 and E2 will be 120 degree. Fine. Where we are going to use it, that will tell you. Now, electric field E1, okay, due to Q, let me write EQ, is equal to 1 by 4 pi epsilon 0 q by a square, right? Because the side given of equilateral triangle, it is a, so a square. Fine. Can we write this EQ? Then second one, E minus 2Q will be, so magnitude, we are taking magnitude. If we are taking magnitude, it will be plus only. So 1 by 4 pi epsilon 0 2Q by a square. So you see 1 by 4 pi epsilon 0 q by a square, 1 by 4 pi epsilon 0 q by a square, both are common here. So can we write as due to EQ is equal to E, electric field. So E minus 2Q, the magnitude we can write as 2E. We can write as 2E, right. Now we will be utilizing the parallelogram law. We will be utilizing the parallelogram law to calculate resultant. And in this case, the resultant will be ER will be equal to whole root E1 square, that is E square, plus second one 2E whole square, plus twice E1 E2. The formula of parallelogram law is E1 square plus E2 square plus 2E1 E2 cos theta. Cos theta is the angle between E1 and E2. So here it will be 2 into E into 2E into cos 120 degree. Cos 120 degree. That's why I told that 120 degree it is. Okay. Now further. Here E square plus 2E square. It means 4E square plus E square, 5E square plus cos 120 degree is equal to minus sin 30 degree. Minus sin 30 degree is minus 1 by 2. So we can place as 2 into 2E square into 1 by 2. So this 2 will get cancelled and square root. Then further 5E square minus 2E square will give you 3E square, and which will be equal to E root 3. Okay. So the resultant will be E root 3. So what E is? Q by 4 pi epsilon 0 A square. So you can say that root 3 Q by 4 pi epsilon 0 A square will be the resultant electric field. Magnitude also we can find, and direction of the resultant electric field will be in this direction, okay, towards minus 2Q. It will be towards minus 2Q. Fine. In this way, we calculated few questions on electric charges, electric force, fields we discussed. We also discussed about properties of the charges. We also discussed about Coulomb's law, how it is utilized. And I am expecting that my students, whosoever is watching this particular video, has understood. In case any doubt, you are free to put comment. I will certainly clarify. Thank you. Thank you very much.